Good afternoon, everyone. My name is Daniel Ferrick, and I'm the Alumni Relations Officer at Trinity Development and Alumni, and it's my absolute pleasure to welcome you to today's Inspiring Ideas at Trinity webinar, Climate Change, a Multidisciplinary Challenge. Today, I'm delighted to welcome our host, Professor Sylvia Draper, Dean of the Faculty of Science, Technology, Engineering and Mathematics, or STEM, here at Trinity, as well as our two fantastic panelists, Professor Jennifer McElwain, Head of Botany here at Trinity, and Professor Laurence Gill, Professor in Environmental Engineering, here also at Trinity. Our panel will discuss how Trinity's research and educational programs are informing our understanding of the drivers and impacts of climate change, and will also discuss the new flagship development from Trinity in engineering the environment and emerging technologies called E3. Our alumni continue to show a deep interest on the topic of climate change. And at the end of this webinar, I will speak to our new series on building smart and sustainable future cities that will run from March to June. The discussion today will last around about 50 minutes to an hour, including a Q&A from the audience interwoven into the conversation. Please do send in your questions as they occur to you, because the audience panel interaction is always one of my favorite parts of the webinar. Thank you to those of you who submitted a question in advance of today. We hope to wrap up this webinar by 2 p.m. Irish time. Now I'd like to introduce Professor Sylvia Draper, the Dean of the Faculty of STEM, who will then introduce our two other panelists. Professor Sylvia Draper is a Professor of Molecular Materials in the School of Chemistry at Trinity College Dublin. Her personal research focuses on developing new routes to functional materials for application in optoelectronics. She was awarded the Institute of Chemistry of Ireland's prestigious David Brown Award in 2018 for her role in furthering inorganic and coordination chemistry research. In 2019, she became the Dean of the Faculty of STEM and has held a number of leadership positions here in the university. She has also served in a number of key bodies internationally, most notably as the European Research Council panel member and as an Irish representative on the Royal Society of Chemistry Dalton Council. A lifetime advocate for diversity in education and scientific research, Sylvia is the academic sponsor of the E3 initiative, the multi-million project in engineering, environment, and emerging technologies. Dean, thank you so much for being with us here today, and I will now hand over to you to introduce our other two panelists.
Daniel, thank you very much. And before we begin, thank you all for joining in today in what I think is going to be listening in on a conversation. So joining me today are Jenny McElwain and Laurence Gill, and together I suppose we represent three disciplines. I'm a chemist, Jenny is a botanist, and Laurence is an environmental engineer. And so we probably bring three very different perspectives to the challenge, which is climate change. So let me introduce my other two much more eminent panel members, and that's Jenny. So Jenny McElwain she holds the 1711 chair of botany in Trinity College Dublin. So it's one of the oldest chairs in the university. She's also the head of botany, and the director of the Trinity Botanic Gardens, and I'm sure many of you have walked around them. Her research and teaching focuses on the evolution of plants, as you would expect, climates and atmospheric composition. But that's over the course of millions of years. So also includes fossils, chemical isotopes and botanic archives. So she's chair of the Royal Irish Academy Committee on Climate Change and Environmental Science. She's a highly respected researcher in her areas, and she's also won an award for excellence from the President of Ireland. So Jenny, you're very welcome.
Thank you.
Hi, Jenny. And then Laurence. So Laurence has spent a lifetime looking at environmental engineering in the School of Engineering. He's a professor there. His research involves studying the fate and transport of air and waterborne pollutants, both in the natural and the built environment. So he's done a lot with wastewater treatment. He's looked at passive and treatments, eco-hydrology, greenhouse emissions, looked at the karst hydrological catchment areas. He has an interest in mathematical models to help us to gain further insight into some of these really very complex processes. And he's also one of the key members, one of the principal investigators of the of a national centre for applied geoscience research called ICRAG. So again, Laurence, you're most welcome. And hopefully we can just pretend that there aren't 400 people listening in and try and just shed some light on what climate change really means. So I think perhaps as we are all scientists and we're all academics, we probably ought to say why scientific research, in our view, is so important to bring to the table in any discussion on climate change. So I might ask Jenny if you might just tell me what you think.
Yeah, thank you, Sylvia, and thank you for the introduction, and hello everybody. Thanks for joining us. So I suppose climate change, we all know it's such an incredibly complex problem. And I think we need research in every single discipline of a modern university to address it. And I suppose giving you a perspective from the natural sciences, you know, just even defining climate change, we need research to understand how you measure it. So climate is 30 years of weather, but global climate change, you need data from 30 years of weather measured over the surface of the entire Earth, the land surface, the ocean surfaces. So that alone is huge. And then you need to be able to say, well, what is driving climate change? And you need to undertake the research and the stock taking to understand that it's an anthropogenic, a human driver. And then we need research to try and come up with solutions and to understand the complexity of the system. So for me, I think my own expertise is in carbon. And we know that the driver of current climate change is an increase in carbon in the atmosphere. So in order to say something about how it's going to change in the future, we need to understand from a research perspective the relationship between, you know, if you put this much carbon in the atmosphere, how much globally will the temperature change by? But then we need to translate that, and we need the research to do it, to go from global to regional and to local. And then you need the research to understand the potential impacts. So for example, a global temperature rise of 2 degrees centigrade, which is the Paris Climate Agreement, we want to maintain Earth's temperature below that level. It sounds very little, but if you translate that onto the ground in Ireland, it is going to mean a change in seasonality, the length of the seasons. It's going to mean a change in flooding, a change in intensity of storms. And then suddenly that kind of abstract 2-degree global warming translates to an impact on agriculture, livelihoods, how we live, biodiversity. So for every step of the climate change route, what drives it, what causes it, how do we predict what's going to happen in the future, how do we come up with solutions? It needs research to answer all of those fundamental questions.
Yes, I think you're right. I'm also, so at the moment, I think the CO2 emissions, so the CO2 ppm in the atmosphere are at some of their highest, has something like 417 ppm, which I think was the highest ever. So it's difficult to imagine how we can claw back from that. So I suppose on one side, we can do the measurements. On one side, we can prove that there is change. And then on the other side is actually adapting the way in which we live on the planet and also the technologies that we adopt. So I suppose that's where engineering comes in, Laurence. In your, I'm curious to know what you think.
Yeah, so I mean, like Jenny says, I mean, I think research is critical to generate data from which we can derive better understandings on all different facets of the challenge. And it strikes me there's 3 different areas that are needed. So one is the production of CO2 and other climate gases, how we can reduce that by different types of technology, for example, for you know, producing energy, for reducing the amount of energy we use in the first place. The second aspect to me is how we can try to actively reduce the carbon in the atmosphere by changes in land use possibly, or geoengineering type solutions that actively try to strip out some of these gases. And then the third element, which we get involved in as well in engineering in terms of solutions, is maybe accepting that climate change is occurring and making predictions into the future as to the impacts of climate change and how that will impact on us. And then we are forewarned and we can develop more resilient plans. So I work, for example, a lot on hydrology. So we can look at how likely is flooding to occur going forward 20 years, 40 years. And that gives us time to adapt, hopefully, to the changing climate. Another thing that we, from a research perspective, that we use a lot in engineering is that we use data to develop models, numerical models, and then we can make predictions into the future as to how the weather might change, and then how that may impact on infrastructure or agriculture, for example. So yeah, engineering is typically kind of solutions driven sort of discipline, very applied, and we need the fundamental research to generate the data and the understandings from which then we can extrapolate forward and come up hopefully solutions in these different areas that can either reduce the amount of greenhouse gases we're producing, try to take some in, or adapt going into the future. That's the way I kind of see it, I think.
So I think from a multidisciplinary perspective, because so many scientists have put their own expertise on the line, we can be confident that the policies that say, we must try and reduce the temperature rise to below 2%, that we must try and reduce, there's a tipping point. Are we confident that we've predicted where the tipping point is? And are we confident, therefore, that the policies have got the right benchmarks?
Yeah, that's a great question, Sylvia. So I suppose the policy framework that most people would be very familiar with is the Paris Climate Agreement. And the Paris Climate Agreement aims to maintain Earth's global temperature below 1.5 degree warming, above pre-industrial if possible, but definitely below 2 degrees centigrade. And the reason it was set at this is because we know that above a global warming of 2 degrees centigrade, you begin to see feedback effects on the climate system. You can exceed thresholds. So these are thresholds for biodiversity. These are thresholds for physical properties of the atmosphere climate system. And there is a body of scientists who, and I would agree in some ways, that they don't like the idea of thresholds because, of course, humans like deadlines. We like to leave it right to the deadline, or we like to behave right up to the threshold before we act. But I think it's a very powerful policy, kind of multinational policy framework, because it sets us a target. If we maintain Earth's global temperature below that target, then we have some chance of maintaining the equilibrium that we're used to. And you mentioned that CO2 concentration currently is 417 parts per million. And the type of research I do and that of my colleagues is we try and put this into a deep past or a historical context. And actually, if you look at the geological past, we know that CO2 concentrations now are higher than any time in the whole of human evolution. So as a species, even as the primate group, we've never experienced an Earth where CO2 levels are as high as they are now. So I think it's a really excellent example where science has informed the multilateral policy. And there is a feedback that policy framework has also challenged the scientists, because actually, up until the Paris Climate Agreement, the models hadn't been run, the climate models hadn't been run at 1.5 degree warming versus a 2 degree warming. So this was thrown back to the scientists to go and try and understand what's the difference. Can we push it to 2 degrees, or do we really have to keep it at 1.5 degree warming? So there's a whole body of science that's come out now. And it obviously, the sooner we act, the better, and the lower we can maintain the warming, the better.
So yeah, I think you're absolutely right. And of course, the Paris Agreement was in 2015. So we have got another 6 years of very concrete data to throw back at the policymakers. But you can also see that there's some really extraordinary challenges that have been laid down for us within sort of things like the EU Green Deal or the green missions, the Horizon Europe missions. And some of those are things like by 2040 to have a zero carbon city. Have we any hope, do you think, Laurence, of getting there? And how should we approach that kind of, you know, almost trying to create pilots that we can stress test and show what might or might not work?
Yeah, I mean, I think it's the aspiration to have zero carbon cities is great. I have my doubts whether we'll totally get there. And I think sometimes people view carbon from, that they can emit certain fundamental aspects of the equation, if you like, the carbon balance. I mean, when people look at, say, renewable energy supplies, I think renewable energy supplies can supply our day-to-day electricity, for example, that we use in houses. But what's missing there is the massive amount of energy that goes into making products. This embedded energy that's often in some ways it's much larger than the normal energy that we see as kind of humans around us. Switching on lights, driving cars, etc. And so I guess by offsetting the carbon, you could probably get to a zero carbon type solution. But in terms of the actual manufacture, I still feel that there's going to be a net production of carbon, which is inevitable in just humans living day-to-day lives personally. But the more we can change our lifestyles to reduce consumption of these products that require a lot of energy, the less energy directly we use, the way we change our travel patterns, all this is all helping to reduce down the carbon emissions up into the atmosphere.
You also hear kind of terms like things like climate resilience. What maybe I'll direct this at you, Laurence. What does climate resilience mean?
Well, I suppose it's how how resilient. That's not a good answer. How safe we are within within a changing climate. How we can adapt to that condition, still maintain our homeostasis, for example. So one thing I look at, for example, is a lot of ecology in wetlands. So in varying rainfall patterns, for example, this impacts on the wetlands and it impacts on the ecology of the species. So some species can tolerate quite wide conditions. They can be dry for a summer for 2 or 3 months, and then they come back. But other species, if they're dry for 2 or 3 weeks, they die out. So those are less resilient. And the same, with humans, how often can we tolerate large-scale winds coming in that maybe it damages buildings once every 3 or 4 years? Do we accept that, or every 3 or 4 years, or is it once every 10 years, once every 100 years that type of damage is deemed acceptable? And then more importantly, some of the larger scale infrastructure, water supply, will we start to run short of water? Will there be flooding, increased flooding, etc.? All these, how do we adapt as a society to that, and what do we deem as is acceptable? There's acceptable, and then there's also actually direct impacts on our health, and potential fatalities coming from some of these impacts of the climate.
So I guess in a way, I suppose climate resilience is also connected sort of to things like biodiversity, because we're seeing certain species are unable to adapt to cope with the changes that are now manifest. So is that true, Jenny? And why is biodiversity important?
Yeah. We know now through research that we cannot consider climate change and the future of climate change and the solutions that we develop for climate change without considering biodiversity. And The reason we have to consider them both together is they're so intertwined. So, for example, a warmer global climate would translate to, a warmer local climate, but it could change the seasons. That change in seasons locally could have a negative impact on one species, and that species could be one that we need for our food. But it could have a beneficial impact on a disease vector or a disease. So we need a fundamental understanding of ecology, how different species in the living world interact, how they are influenced by and interact with their kind of abiotic climatic surroundings. And we know that most species have what we call a climate niche or a climate envelope. It's this kind of climate space they're adapted to. And what they tend to do through studying the past and the present is, as climate changes, the species tries to move to keep its climate envelope, and it moves somewhere. But what this does is that this places species that have never interacted before with each other. And this is when you get new diseases. So in a way, COVID and other diseases that are emerging, this is partly due to the biodiversity crisis, but future diseases may emerge because the new climate, the new weather system due to global climate change may preferentially enable that particular species to spread at the detriment of the species we need for our food, or that has no detriment to, let's say, plant health or human health or agricultural livestock health. So we have to consider both.
It's sort of an ecological consequence, doesn't it, for us as a human species? Because you can imagine that if our climate becomes more moist and more tropical, that then exposes us to different types of, virus than we've been exposed to before. So, and I guess also about biodiversity, there is quite a lot in the newspapers recently about, rewilding, repopulating land masses to kind of, bolster up biodiversity or return to the sort of the natural resource that was there. Can you tell us a little bit about that, Jenny? What you think?
Yeah, so I mean, there's been some really nice rewilding experiments. A fairly famous one is in the UK in Napa State, and rewilding was initially established or set in train to bring back biodiversity that was lost from intensive agricultural landscapes. And it's very positive for biodiversity. So species that hadn't been seen before, like the larks in this estate, had come back, and you get a change in the vegetation structure. So you get things that farmers would be horrified with, frankly. They'd look at fields of ragweed and thorn bushes, but these provide natural refuges for trees. And the trees, because they're protected by thorns, are not grazed. So natural regeneration of forest, you can do this without planting any trees. You just let it naturally take place. Happens in rewilding sites. So it's now emerging, and it's still very early research, but rewilding sites is positive, not only for biodiversity, but it has a climate impact, a mitigation impact, because the soils in rewilding sites often store more carbon. And if you've got natural regeneration of woodlands, then you've got this new stock of carbon. But there's still a lot of research to do. And of course, we're faced with the challenge of, well, we can't rewild everywhere because we still need to feed ourselves and we still need agricultural land. So I suppose this gets to the complexity of climate change and climate change research, and why we need everybody. We need all expertise trying to come up with solutions, because I suppose a solution for ecological biodiversity may have a negative impact on climate change and vice versa on climate change impacts.
It's really fascinating, isn't it? And I always kind of think of the world as multiple interconnected equilibria. That's because I'm a chemist, and I kind of think you fiddle with one and you have unexpected and maybe unanticipated consequences somewhere else. And so we don't understand how the human body works, let alone all the ecological equilibria that interconnect in the planet. But coming back to kind of land use and, you know, what you might be able to do with so I know that, Laurence, you have a real interest in bogs, and, you know, we can't, you know, we can't cut turf anymore. So is the bog to be protected as a, you know, we don't touch it because it's biodiversity, or is there something else that we can do that means that that bog has a value above sort of wasteland?
Yeah, so I think it's a really interesting time in Ireland in that over the past 40 to 50 years, most of the raised bogs in the Midlands of Ireland have been harvested, mined for energy and burnt. And now the government have this big decision what to do with these vast tracts of land. And we do a lot of research on the eco-hydrology of these bogs. There's a few that are still existing, and so we try to work out what are the conditions that allow these bogs to grow in a natural state. And then other people like Jenny will look at the biodiversity aspects of that. But with these vast tracts of land, I mean, you know, sometimes, as you mentioned, there can be a bit of a conflict between what's good for biodiversity and what might be good from a greenhouse gas perspective. So if you regenerate a bog, so you know, there's quite a bit to do that. But what one idea is to try to get these bogs growing again, regenerating the moss, basically, that, you know, the sphagnum that grows, and they will start taking carbon. And a well-behaving bog in our kind of climate would take in about 40 to 50 grams of carbon per meter squared per year, which sounds, you know, reasonable, and that will just keep going, and it will go for thousands. These bogs have taken thousands, tens of thousands of years to accumulate, and effectively it's a storing solar energy is the way I would see it over all that period of time. But if you want to reduce greenhouse gas emissions as fast as possible, you know, you'd be better putting wind turbines or solar panels on there. But I personally wouldn't agree with that. It'd be, you know, they per unit time will offset, if you like, a lot more carbon emissions as would have been burnt from fossil fuels by a scale of 100 probably per unit area. But that's not, you know, how sustainable are those turbines? The material, again, getting back to the point I made about the material that's gone into them, where did the energy come to make that? How often does that have to be renewed, etc.? And you know, how long are they going to last for thousands of years going into the future? And then the aspect of biodiversity, which is just as important and also entwined with the climate. So I think there's a good example there of this potentials of land use, and as a society we have different decisions to make. And balance, I think. I mean, personally, I would go for the biodiversity, you know, restore the bogs to their former active taking in carbon status in that case. But, you know, these are genuine decisions that are very prevalent now in Ireland, and people are starting to make decisions as we speak now.
Really interesting question, and I know that you might be able to tell us a little bit about it, Laurence. And it's, we always think that, you know, in the Western world that, you know, we've had the advantages of being able to have the Industrial Revolution and progress to sort of technologies. But do we have some lessons to learn at this point from the developing world? And do you think that they are perhaps got, you know, an ability to recognize what it really means to have limited resources?
Yeah, definitely. Yeah. So, I mean, apart from working on the bog site, I do a lot of work on water and sanitation type solutions, and particularly in developing countries. And, you know, I think in the past in Western countries, we've had the benefit of relatively cheap supply of energy and technology. I mean, we've developed these very high technological, high energy type intensive solutions to centralized treatment systems, you know, wastewater, water, pumping water around, and the energy cost really has been relatively low. You know, sort of fossil fuels have sort of been subsidized a lot, and whereas in other places where the energy has been much more expensive relatively, or hasn't been there. People have developed more kind of passive treatment solutions. And certainly from my perspective, I now bring a lot more of those type of more passive treatment, like using the soil as a form of treatment, using sunlight, for example, to treat water, into my teaching and my research now, as a much more sustainable way to move forward, from a technological perspective, to recycling byproducts, etc. And I think a lot of these countries have almost been forced to adapt into those lower, less intensive, more passive sort of treatment type solutions, which now are coming much more to the fore in terms of the thinking, more global thinking, in sustainable development goals, for example. So yeah, it's very interesting, this mixing of technologies and ideas, I think, backwards and forwards.
Yeah, and so you can, being portable, having a portable device, having a solar panels, because there is not widespread electrically, you can't just turn on a tap. So therefore the drivers for the Western world in its economic development have now been sort of a little bit turned on their head. And that linear resource model, which was driven by cheap energy or cheap resources, has sort of turned around. So I think you're absolutely right. It also kind of connects with a change in human behavior, and thinking about the world of plenty actually is not an infinite resource at all. And kind of reevaluating. Do you have a sense of how we should measure environmental impact? So there's three of us here. There's a chemist, and I might say, well, if you look at nuclear energy, its capacity percentage it's very, very efficient. But then from a biodiversity and environmental point of view, Jenny would say we shouldn't go down the nuclear route. So how do we pull multidisciplinary thinking into measuring impact? What do you think, Jenny? Do you have a...
Yeah, so it's so difficult. It's really difficult to answer. I would kind of refer back to the Green Deal. So Europe's Green Deal, and they want the ambition is to reach zero carbon by 2050, but to do that fairly for society, and to recognize that some workers will not have the same job, so a just transition, and to decouple economic growth from carbon emissions. This is so difficult, and it just shows you can't do it without. You need a lawyer, you need a behavioral psychologist, you need an economist, you need a botanist, an engineer. You need, the only way you can actually measure the impact is if you consider, as you talked about, the whole system. So I think we need not just multidisciplinarity, we need like this interdisciplinarity, where we really moved out of our comfort zone, and where the scientists work with artists and creative practitioners and lawyers to try and properly measure the impact. But I think some of the major climate reports are beginning to do a really good job. So they're measuring the impact of some of the solutions against the sustainable climate goals. So for example, offsetting. So some people will fly internationally. You could offset your flight by putting money into planting trees. And that makes you feel really good and warm and fuzzy, but in actual fact, if those trees are planted in the wrong place, they may sequester carbon, but if they're in a place where fire is natural in the ecosystem, they will burn down, and the carbon stocks not only in the tree, but also in the soil will be lost. So planting a tree in the right place, not in the wrong place, is important. And that's why I think measuring the impacts of some of our solutions, it has to consider all our knowledge and all our disciplines so that we come up with the right solution. Because if it stays within a discipline, we will we will each come up with the wrong solution, and we'll measure the impact wrongly, and we will have one of these unintended consequences that you talked about, Sylvia.
Yeah, I think so too. I think also many individuals, and particularly, you know, the younger generations, are really wanting to change their behavior. They recognize that they're going to be the people that will see, you know, the growing consequences of temperatures rising, etc. And sometimes as an amateur sustainability guru, you can be fed the wrong information. So, you know, little things like, you know, you can be tempted to buy something because it says it's biodegradable, but actually when you interrogate what biodegradable really means, it actually is, well, everything biodegrades, but you're not told how quickly or by what process, or, you know, it's quite different from compostable, you know, so that you kind of, you know, you're kind of sort of fed information, and it affects behavior in a way that maybe isn't necessarily the right way. So I'm wondering, Laurence, do you have a view from an engineering, because you did talk about measuring the cost, if you like, of producing something in the first place. So then that makes me wonder, should we be worried about, we should be concentrating on recycling, reusing, refurbishing, you know, replacing rather than renewing. What do you think?
Yeah, I mean, the concept that they have this waste hierarchy concept where, you know, the best thing is not to produce something in the first place, and the second thing is to reuse, you know, material. I mean, I think it's now becoming quite well developed, this whole life cycle analysis approach to study anything, you know, any product or that comes in. So you take it from where the original materials are dug out the ground, how much energy was involved, what damage did it do maybe to the local rivers, how much energy was used in transporting it to, say, Ireland, how much energy was used in manufacturing and what materials. And there are all these different global indicators that you can assign to any product. So you can look at what impact did it cause in terms of ocean acidification, what impact did it cause in terms of greenhouse gas, what impact did it cause in terms of nutrient enrichment, what impact did it cause in terms of toxic materials. And so this sort of life cycle assessment approach sets all these different contexts out. So it's like Jenny saying, you know, from all these different perspectives, but biodiversity, what impact did it create on biodiversity? And, you know, some will fare quite well, some products might fare quite well on one aspect, but very poorly on another. And then the whole life cycle assessment, the life bit of it is that it's not just producing the material, it's what happens to it at the end of its life. Can it be recycled? Can it be reused? And then how does it break down, etc. So I think this thinking is very much coming much more into the analysis, the thorough analysis of all our impacts, and this has to be taken particularly from an energy perspective. You know, so much of the energy that really is burnt from fossil fuel perspective is used in producing material, concrete, steel, you know, and aluminium and all this, and that needs to, we need to produce less of this, but equally that really has to be factored into the thinking in terms of proper quantification of how much energy do we as a society, as a world, need going forward, how much can we sustain, and where does that source of energy come from if it's not coming from burning carbon. I'm going
to try and turn a little bit to the questions that are coming in while we're talking. So we have a question here. Should we be putting as much effort into mitigation of the consequences of climate change as we should, like things like flood barriers, or thinking about tracks around forests, so that if we do have fires, we could control the fires? Should we also be putting effort into mitigation?
Yeah, I mean,
prevention.
I mean, I think we should be putting our efforts into all of it, you know, mitigation, adaptation, but ultimately we need to reach that zero carbon target. And a nice analogy is the COVID curve. So we're all so familiar now with COVID, and you know, there's a life cycle of the disease. If cases start to increase, the longer we leave a lockdown, the harder it is to bring that steep case curve back to its former level. And it's the exact same with the carbon cycle. So we know we want to flatten the carbon curve, just like flattening the COVID curve. The longer we leave it, the more drastic the measures we'll have to take in the future. So if we start gradually meeting our national targets in carbon reduction, then we can do it smoothly and in a manageable way. The longer we leave it, not only will we have to get to zero carbon, we'll have to actually go into negative carbon. So we'll have to actually work out a way of taking carbon out of the atmosphere, in addition to stopping burning fossil fuels, and you know, to maintain Earth's temperature below 2 degrees. So I think the COVID analogy is really good. So sorry, I didn't really answer the question on mitigation, but I kind of think that the core, it doesn't matter what we do, we have to meet these carbon targets, because then at least we can put all the other measures in place to look at, you know, some of the consequences in terms of flooding and pests and disease. But we have to sort the carbon out.
We have a comment from Keith, and I absolutely take it on board. When we talk about zero carbon, what we actually mean is zero net carbon. So Jenny said when she says about negative, what she means is essentially sequestering the carbon. I mean, there are sort of plans to create materials that will absorb CO2 that we can then kind of encapsulate and bury. You know, this is sort of what, you know, it's the net carbon, as with all, you know, the conservation of masses, which is a chemist's term for, you know, the amount of carbon is the amount of carbon. What we're trying to do is to change it from being atmospheric carbon to being something else, something that is not contributing to the atmospheric increases. I have another question here. What do the panelists believe is the single greatest obstruction to public understanding of climate change and towards a move to a more sustainable way of life? What do you think? Is it inertia? Is it cost?
Well, I think it's because it is so abstract, and we can't see carbon dioxide in the atmosphere. Okay. And unfortunately, we don't want to act on something that's so invisible. We only start to act when the impacts affect our daily lives. And in some countries, you know, like low-lying Pacific islands, they're being impacted now because they can see the effect of sea level rise, and equally Inuit communities in Greenland, they are seeing the effect of melting glaciers. But Ireland, we're kind of very buffered by the ocean, so we're not seeing really visible impacts just yet. I mean, we are with flooding and things like that, but I think that's what it is. We've got this terrible habit of not wanting to react to something if we can't see it, and it seems abstract and it seems somewhere else.
Yeah, I think that is true. What do you think, Laurence?
Yeah, I'd agree with Jenny to some extent. It does seem a bit distant to some people in the world. I mean, I think the biggest obstruction to it is the whole way the world is based on consumerism. That the whole economic structure has revolved around that, and you know, it's that's driving it. You know, rising populations consuming more and more materials, burning more energy, and that whole economic model in the part, you know, has to change, I think, and we have to value carbon more for what it is and the damage it does to the environment, which requires a sea change in the way humanity thinks, I believe. But it does seem to be turning a bit. You know, more people are talking about it, and like you say, the younger generation are definitely fired up about sustainability in general and climate as well. You know, linked to that. So I do see it happening, but that to me is the driver really of a lot of this, I think.
It's in a way, it's a shocking indictment of the human species, but it's at the point where we're close, that we are at the close to extinction, that we'll become most creative, and we make technical leaps to save ourselves. So we have to believe that as an intelligent species with a desire to survive, that we will put our energies into this before it becomes too late. I wanted to ask a little bit about, what do you think Trinity as a university can do to maybe address this, inertia, it's not real, it doesn't affect me, kind of, what I guess it's education. But I'm trying to think, I know you, Jenny and Laurence, you've been really actively engaged in generating a new undergraduate degree course that's trying to do just that. So maybe you could tell us a little bit about the education piece.
Yeah, so, well, I think I would agree with Laurence there. I'm really hopeful because of the younger generation demanding better. And also the younger generation are so good at finding knowledge and looking for information. And I think what we can do as a university is to provide multiple sources of information, combine our knowledge and our expertise in a very multidisciplinary way, because it's a so-called wicked problem that needs complex solutions. So I think that the course that Laurence and myself have developed, environmental science and engineering, it's doing just that. So it's really quite unique. It's bringing the perspective of the natural scientist and the engineer, and from day one for a 5-year undergrad and integrated master's course, teaching through teams and learning through experience and design and understanding the multifacetedness of the issues. And I think we bring very different skill sets, the kind of natural sciences and the engineer. I think the next step in the E3 kind of family is building out even further, because scientists alone aren't going to solve it, and engineers alone. We need to go much further and involve all the other brilliant minds and disciplines in college. So I think that is the way forward, providing the space and the knowledge to the next generation, so that they can, answer your question, how do you measure impact? And they'll do a good job of it, because they'll have the training that we're very discipline specific at the moment.
And I think one key part about the course is going to be very challenge based projects moving through all 5 years of the course, with the different generations in the course all intermingling but focused on a challenge, and then bringing people in from other disciplines outside of environmental science and engineering. So which is the way we need to operate to deal with these global challenges. They're interdisciplinary, multidisciplinary project problems. And so if students from day one are operating in this way, this is because, it's natural to them in a school environment. They do lots of different disciplines, and it's when they get to university we become very channeled, I think, in our thinking. Maybe not so much recently. I know in engineering we've broadened out a bit more, but traditionally everybody narrows in too much. Now we do need to retain that specialism as well. We need experts, but we need people to be able to think more broadly and in a more kind of systems perspective. I think, which is tricky. What are these unintended consequences that you're talking about? Knock-on effects. If you tinker around here, what impact does that have somewhere else? And
there's a question about multidisciplinary here, and have we got examples where it's worked well? And I suppose I might be able to tell you a little bit about that. So we have quite a lot of master's courses now that involve combinations of things like climate entrepreneurship. We're also doing a lot of postgraduate and professional diplomas, which are training economists to think in a sort of a sustainability, pulling sustainability into the way in which economic drivers happen, and also to look again at the way in which to manage human behavior. So we also have really interesting programs being developed between social scientists and psychologists with business, economics and engineering. So a real mix. I kind of feel that climate change is by its nature a disruptive event. And actually, it's going to change the way in which the university operates. You know, we have been very discipline orchestrated. You know, I'm the faculty of STEM. There is another dean who's the faculty of Arts, Humanities and Social Sciences, and another dean who looks after health sciences. But actually, as we've seen, biodiversity affects human health. You know, human health is impacted by environmental health. The environmental sustainability impacts on economic drivers. So all of these things are now interconnected in a way that we didn't really appreciate when we were perhaps trained ourselves. So it's also a case of having a common language. So that you know, it's much easier to be bilingual if you're brought up with the two languages while you're being formed, you know, and I kind of think that undergraduates, their formation, their technical development is still in its embryonic stage. So that's the moment where you can really open people up to other disciplines, and it's easier in many ways than to try to do it later, you know, to have a sort of, you know, a very narrow channel of expertise and then to try and broaden out. It's usually easier to be exposed early because I think it influences the way in which you take in your own discipline specific expertise. We have one very discipline specific question actually, Laurence, and it's on dry sewage treatments.
Right.
Can you tell us a little bit about that? We're nearly coming to the end.
So the question is just, what do I think of?
It says, Laurence mentioned dry sewage treatment systems. Can he elaborate a little more on types? And if such systems can be applied to larger scale cities and towns, could it improve water quality? Like, has it got advantages?
I mean, personally, I work more on decentralized, small scale systems that do use water. So, you know, in Ireland, we're never particularly short of water as a transport mechanism for the sewage, and then that. But there's ways of dealing with that at a much local scale using soil treatment, etc. But there is the concept of using more dry systems, so composting toilets, etc. And if they can certainly work very well, and you can also reuse the material as a fertilizer. There's been more research done on that in Scandinavia, and also, of course, in a lot of African countries where things like pit latrines are much more common form of sanitation. And I've been working with some guys in South Africa looking at the efficacy of that from a public health perspective, which is very important, but then also from a protecting the environment perspective. Both from not contaminating water supplies, but then also can we reuse the materials, the compost and nutrients, etc. I think generally dry toilets can work very well, and they can work in an urban scenario, but they do require a high dedication from the user, much more than say our conventional toilets, where we sort of flush it away, and most people don't know what happened. You know, in Dublin, you flush the toilet, people probably don't really know what happens to the wastewater, and that's one of the reasons I like this decentralized approach, where people are much more involved with their water supply coming in and the wastewater going out, that they understand the system much better, and they're more likely to act in a sustainable way if you understand, you know, what's going on. So yeah, I mean, the short answer is yeah, it can work very well, but it does require high dedication from the user.
Thanks very much, Laurence. There's some fascinating questions, which we probably can't go into all of them. There's a question about bioluminescence, which again is really interesting. You know, jellyfish are a great example of chemiluminescence, where they trigger a reaction, and of course you have fireflies. And could this be a way to create light? And I suppose my research looks at different ways in which to use light, because a kind of light is a resource that is all around us, and the sun, at least, although it's a dying star, is going to last a long time. So yes, I think there are lots of opportunities to use light in a very effective way, including in as a light source, but also as a source of energy. So yes, there is a lot of research going on in perovskites, in solar cells, and also looking at bioluminescence. So you can actually create biological species that luminesce, even though they might not naturally luminesce, and that touches on genetics. There's also a very nice question that says, should E3 be E4? Should we include economics? But I think we could open it up to so many E's that it might be challenging to do, but it is open to economics. So emerging technologies depends on economics, but it's E3 is, I suppose it's a sort of a way of thinking about 3 dimensions, and thinking about, a 360 view of what we need to do for climate change. I suppose there is one other question that maybe we could touch on, and that is, should we all, it's complex, but everybody wants simple instructions. And one of the questions is about meat eating. What do you think, Jenny, in terms of how we should modify our behaviour?
I think it's been demonstrated by looking at the life cycle analysis, the carbon footprint, the water footprint, that is one measure that an individual can really make an impact, is to reduce your meat intake, reduce it by half, or cut it out altogether. That is very difficult for a lot of people, but even by going down to 1 beef day a week, or 1 beef day every 2 weeks, would have a measurable impact on the water footprint of agriculture and the carbon footprint. And the carbon footprint is through methane, and methane as a gas is 25 times more potent than CO2. So this is why Ireland, this is why we are, number 4 per capita in Europe in terms of carbon emissions. It's mainly our methane. So there's a lot to be done to support agriculture, and through consumers and government action. But one way we can do this is to actually reduce our meat intake. And I have to say, I do eat meat. I'm not a vegetarian, but I am strongly considering going down to 1 day per 2 weeks for beef.
Okay, thanks very much, Jenny. So Daniel has reappeared. I just wanted to say one last thing. Maybe if I could say it to Jenny and then to Laurence. How do you think Trinity should take the lead here, and how can we make Ireland a kind of, exemplar for what we should be doing?
I think we can take the lead through our new courses, education, through our new research institute, E3, and by making Trinity East an exemplar for everything we've talked about today. So as we develop a new campus, we should have the ambition to make it net zero carbon, or even better, carbon negative, where we generate electricity and generate biodiversity, and try and use that to offset our older campus.
Thanks, Jenny. And Laurence?
Yeah, the same as Jenny. I mean, we need to lead by example. Any new development needs to be as low carbon as possible, and then also through education, like this new degree that we've developed, that is focusing much more specifically on this global challenge. So.
Thanks very much, Laurence. Thanks very much, Jenny. It's been fascinating to talk to you. I could spend another hour, but we're not allowed. So thanks very much.
Sylvia.
Thank you, Dean, and thank you very much, Professor Jennifer Mc Elwain and Professor Laurence Gill, for giving your time and expert insights to us today. Before I go, I'd just like to say a few things. Firstly, a sincere thank you again to all of our speakers for their time today. I'd also like to thank the Trinity Development and Alumni team here who helped bring this webinar together, and a special thank you to Alex Owens and Aoife Brady from the Events and Comms team who really helped bring this webinar to fruition. Lastly, I'd like to thank all of you for listening today and for your enthusiastic engagement by sending in your questions and comments. I'm sorry we couldn't get to all of them, but we will try. to get to as many as we can in the next webinar. On the screen, you'll see links to the E3 website. We encourage you to go check this out if you need to find any more information about E3. If you have any more general queries or comments regarding the webinar series, please email us at alumni@tcd.e. We're always happy to hear from you. In the meantime, our next Inspiring Ideas at Trinity webinar will take place at the same time. That's 1 p.m. in 2 weeks. That will be March the 10th. The webinar is entitled Diversity and Inclusion and will include 3 highly distinguished speakers: Dr. Maeve Hand, former president of the Trinity Women's Graduate Association, Dr. Clodagh Brooke, Associate Vice Provost for Diversity and Inclusion here in Trinity, and Vivian Rath, PhD candidate and lecturer in higher education, disability and human rights, also here in the university. The panel will discuss equality, diversity and inclusion. How far have we come? A Trinity perspective on the latest advancements and challenges in this space. And finally, following today's truly excellent webinar, we'll be launching a mini series of webinars called Future Cities. This series is bringing together leading academics and regional experts to discuss the research, challenges, and innovation that are part of developing smart, sustainable communities. In particular, the series will focus on how research, education, citizen engagement, urban planning, business, technology, and innovation are all playing a key part in shaping our urban future. The series will also address the unique challenges and priorities for each of the cities featured. The series will be launched on March the 2nd by Mary Robinson, former President of Ireland, and Professor Anna Davis here in Trinity. Registration information for this webinar will be included in the follow-up and an email invitation to alumni as usual. We hope to welcome you here again. Thank you so much, and thank you again to our speakers. Do stay safe. Goodbye.